Alrighty, we're at Trig lecture 825 and 826. The student will use the Pythagorean theorem and the definitions of trig functions to find the value of an indicated trig function. These are the exact same instructions that we had for our last two assignments, but today instead of finding the values of sine, cosine, and tangent, we're going to find the values of cotangent, secant, and cosecant. Very similar. Here we go. Again, we're going to run into theta and alpha. They're just variables, just like they were in the last two assignments we did. Our trig ratios, of course, are defined as the sine of theta is equal to, or alpha, or any variable. The sine of theta is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent opposite over adjacent, and these three are the reciprocals of these three. The reciprocal of sine is cosecant, so opposite over hypotenuse, hypotenuse over opposite. Cosine is the reciprocal of secant, so adjacent over hypotenuse, the secant is hypotenuse over adjacent. Tangent and cotangent are reciprocals and cofunctions. They're the only cofunctions that are reciprocals. The tangent is opposite over adjacent, and the cotangent is adjacent over opposite. So there we go. There we go. Let's see if we can do this. We're going to find the cotangent of theta, secant of theta, cosecant of theta from a perspective of this triangle. And I hope I didn't misspeak when I said any of that. I was going kind of fast. I got a map right here in front of mine. Going to find cotangent, secant, and cosecant of theta, cotangent, secant, and cosecant of alpha. So let's start with theta because it comes first. Cotangent is defined as the adjacent over the opposite. So that would be 12 over 9, and we can reduce by dividing top and bottom by 3. 12 divided by 3 is 4. 9 divided by 3 is 3, and there we go. The secant of theta is hypotenuse over adjacent. Right here, hypotenuse over adjacent. That would be 15 over 12. Adjacent means next to. Opposite means on the other side of this triangular room from this corner, so to speak. Adjacent means right next to. Like the room adjacent to mine is Miss Yeager's. We can divide the top and bottom of this by 3. That will give me 5 over 4 if I haven't made any arithmetic mistakes. And the cosecant is hypotenuse over opposite by definition. Cosecant, hypotenuse over opposite. So I'm going to go hypotenuse over opposite, 15 over 9. That's very sloppy. 15 over 9. Reduce the fraction by dividing the top and bottom by 3 will give me 5 over 3. And there we have it. Now we'll find the cotangent, secant, and cosecant from the perspective of alpha. So the cotangent of alpha is the adjacent over the opposite. That would be 9 over 12. Dividing top and bottom by 3 because we can, reducing the fractions, 3 over 4. The secant of alpha. The secant is the reciprocal of cosine, which is adjacent over hypotenuse, so this would be hypotenuse over adjacent, 15 over 9, and we reduce that fraction, and that would be dividing by 3 would give me 5, dividing by 3 would give me 3. And the last one, the cosecant of alpha, is the reciprocal of the sine. Well, the sine is opposite over hypotenuse, so hypotenuse over opposite. 15 over 12. Divide the top and bottom by 3 because we can, reducing the fraction will give me 5 over 4 if I do my arithmetic correctly. That's the kind of thinking we're going to be using. Today we're going to be messing with cotangent, secant, and cosecant, which are the reciprocals of the tangent, the cosine, and the sine. And here we go. We're going to also use the Pythagorean theorem if we are missing the side of a triangle and we need it. If we need it, we'll use the Pythagorean theorem. So here we go. Let's take a look at what we got here. Find the value of the indicated trig function. I'm looking for the cotangent of theta. Here's theta. Cotangent is defined as adjacent over opposite, so I do need to find the length of that side. Here we go. I'm going to say, using the Pythagorean theorem, a squared plus 4 squared is equal to 4 radical 5 squared. This will give me a squared plus 16 is equal to 16 to 80. Alrighty, subtracting 16 from both sides, a squared is equal to 64. Take the square root of both sides, a will equal to plus or minus 8. And because we're looking for the length of a side of a triangle, we're going to ignore the negative root and say that this is 8. If I haven't made any mistakes. I should have used a calculator to make sure I didn't, but I can check my answer here in just a second. And if I did, I'll be embarrassed. Here we go, I'm looking for cotangent of theta. The cotangent is adjacent over opposite, so that should be 8 over 4. That will reduce, simplify to 2 over 1, which we just called 2. And unless I've made an arithmetic mistake, this should be our answer. 2. So let's see if I made an arithmetic mistake. 2. Yay! All right, let's take a look at the next one. We're doing the same thing we did for the last 2 days, but instead of looking for sine, cosine, and tangent, we're looking for cotangent, secant, and cosecant. Here we go. I'm looking for the secant of theta. Well, secant is hypotenuse over adjacent. And so I'm going to have to find this side right here. And I'm going to use the Pythagorean theorem. I'm going to say a squared plus 4 squared is equal to 5 squared. The sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. A squared plus 16 is equal to 25. Subtracting 16 from both sides. What is that? Is that 9? And then we take the square root of both sides. A is plus or minus 3, as we learned in Algebra 2. But we're going to ignore the negative 3 because we're looking for the length of a side. And there is no such thing as negative length. So there we have it. This is our scratch work. I'm going to get rid of it now and just do, well, I could put my answer right here, I suppose. The secant of theta. Here's our theta. Secant is 5 over 3, the hypotenuse over the adjacent. That won't reduce. And so I'm finished unless I've made a mistake. Let me check and see. 5 over 3, 2 in a row. I can't believe it. Haven't made a mistake yet. That's rare for me. Let's take a look at the next one. Looking for the secant of theta again. Well, here's theta. And the theta is theta is hypotenuse over adjacent by definition. I'm thinking this up here. Hypotenuse over adjacent is the reciprocal of the cosine. Cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. Here I am saying hypotenuse over adjacent. Well, I don't need to use the Pythagorean theorem there. I don't need this side. So I'm going to say, well, the secant of theta is hypotenuse, 3 radical 13, over adjacent. I say, hey, I can divide both of these by 2, so I'm going to do that. Or by 3. I'm a brain damaged old man. Dividing this by 3 gives me radical 13. Dividing this by 3 gives me 2. My bottom is rational, my denominator is rational, so I can just stop right there and hope that I haven't messed up. Let's take a look at what the key says. Radical 13 over 2. Radical 13 over 2. Yay! 3 in a row. Can you believe it? All right, let's take a look at this one. We're looking for the cosecant of theta. The cosecant of theta is defined as hypotenuse over opposite. So from here, I have the hypotenuse and the opposite. So I don't have to do the Pythagorean theorem again. Once again, I can ignore the Pythagorean theorem because I don't need this side. I just need the hypotenuse and the opposite. So that was convenient. I'll say the cosecant of theta. From a perspective of theta, the hypotenuse is 5. Excuse me. Hypotenuse over opposite. This won't reduce, so I'm done. Unless I've made a silly mistake. Let's see if I got it wrong. 5 over 3, yay! So there we go. This is very similar to what we just did for the last couple of days, except instead of finding the values of sine theta, cosine theta, and tangent theta, we're looking for cotangent theta, secant theta, and cosecant theta. And we're appealing to these definitions. Okay? You can do this.